First, though, we need to talk about a little bit of terminology. So I'm going to be throwing around a bunch of different terms, and I want to be sure that you know what I mean whenever I say them. So first off, we have theorem, proposition, lemma, and claim right here. So all of these are basically statements, claims that can be proved to be true. And don't worry, I will define what I mean by proving something is true. So all of these right here are statements that can be proved to be true. We have a bunch of different names for them because some of them have different importance levels. So usually when you talk about a theorem, that's like a big thing that you're trying to prove. So for example, in the previous introduction video, when I talked about the set cover problem, you could call that a theorem. It is something big to prove. A proposition is usually something that's a statement that can be proved to be true, but it's not quite as big of a statement as a theorem. A lemma is also a statement that can be proved to be true, but it's usually even smaller, and a claim is probably even something a lot smaller. So while a theorem would be something like that set cover problem from the introduction, something like a claim would be if a is a real number, then a squared is positive, something very small and slight. A corollary, on the other hand, and you might hear some people call this a corollary, but the standard pronunciation is corollary. A corollary is a theorem, proposition, lemma, or claim that immediately follows from some other previously established theorem, proposition, lemma, or claim. So you can kind of think of this as a special case. So if you have a theorem, you've proved it to be true, and then you look at a particular special case of that, you could call that a corollary. A conjecture, on the other hand, is a statement. So it's also a statement, and indeed it can be a logical statement, but one for which no proof yet exists. So nobody has yet proved it to be true. So it's not actually a theorem, it's a conjecture. And usually a conjecture is something that people think might be true, but they haven't yet been able to prove it. So if you are able to prove a conjecture and show that it is true, then that conjecture gets elevated to become a theorem, a proposition, a lemma, or a claim. However, if it turns out that you can show that no, it's actually false, then that conjecture does not become a theorem, it becomes a false statement. And lastly, we have probably the most important definition is proof. So a proof is a valid argument. And remember, we were just talking about arguments, so we know what a valid argument is, and we have a small toolkit, our inference rules, of how to establish valid arguments, or the validity of arguments. So a proof is a valid argument that establishes the truth of a theorem, proposition, lemma, or claim. And usually the proofs that we're talking about are what's referred to as informal proofs. So these arguments are typically informal in that they contain a a mix of English, math, logic symbols, inference rules, etc. So the arguments that we were looking at in the previous section were formal in that we translated it only to logic symbols, and then we used simply logic steps that we had to be able to establish the validity of an argument. Informal proofs are usually a mix of those sorts of formal proofs with our inference rules and logic symbols, but also a mix of English and math thrown in there as well. Because sometimes it's more convenient and allows you to write shorter proofs if instead of translating everything into formal logic, you can simply use an English statement and hope that the reader has an understanding of how that English statement translates over into the formal logic. So that is a proof. This is the terminology that we're going to be using in this section.